Okay, we're going to be working on linear functions. A graph a function whose graph forms a straight line, please fill that in, is called a linear function. That's it. When they talk about linear functions, they just mean an equation or just a function that is oh my goodness, I'm just going backwards. When they talk about a linear function, they're talking about any kind of graph of a line that makes a straight line. That's what makes it linear. Now, I would highlight this part right here because you have to know this for the EOC and all the way through for ever, and ever. A parent function of an equation is the simplest equation of a function, okay? When they talk about a parent function, that's the most basic equation that you can have. The linear parent function, star and highlight, is y equals x, or you can have f of x equals x. You must know that for here and evermore. The linear parent function is y equals x. Linear functions describe numerous real-world situations that involve a consistent rate of change such as cost, distance, and speed. What else did we call the rate of change? Coefficient. And what? Started with an S. Slope. Those all mean the same thing. There are 3 different ways to tell if data is linear. You can do it by a graph. Okay, a table. And by words. So for example, the graph would be a straight line. The table, we're going to talk about when our delta y over delta x is the same. And we'll see more examples of like in words. And I'll show you those examples instead. First off, in tables, ordered pairs, etc., if given a set of data such as a table, ordered pair, or mapping, make a table and find the rate of change. Circle rate of change. Linear functions must have the same rate of change. If a function is linear, find the equation for the data. So what we're going to do here, so we'll go through and do delta y. It's plus 4. This one is plus 10, plus 6, plus 6. Some people tell me this is not linear because these numbers are not the same. You have to go over here and do delta x. Right here it is plus 2, plus 5, plus 3, plus 3. Now let's go and see if they're the same. Delta y divided by delta x, 4 over 2 is 2. 10 over 5 is 2. 6 over 3 is 2. Since these numbers are all the same, my data is linear, meaning it will make a straight line. So what it asked you to do was to find the equation of the line if it did. Well, I'm going to just kind of draw a line in here. You really should do is make a table that's bigger, like going out here. And I told you my favorite number is 0, so I'm going to use 0, -5. And I'm going to put the coefficient in there, that delta y over delta x, what we found here, 2 times the x number, which is 0. What's anything times 0? 0. What do you have to add or subtract to 0 to get to negative 5? Minus 5. So the equation is y equals 2x minus 5. That is linear. I guess I should have put it on, I didn't see it all the way down here. That's okay. The next one, here's another table. I'm going to do delta y. The change in y right here is minus 5, minus 3, minus 1, plus 1. Delta x plus 1, plus 1, plus 1, plus 1. I already see a problem. Delta y over delta x. Negative 5 over 1 is negative 5. Negative 3 over 1 is negative 3. See how these aren't the same? Already, I don't have to do the rest of them. This is nonlinear. If it's nonlinear, there's nothing we can do to find an equation because it has to be linear to find the equation. The next one, delta y, the change in y, minus 3, minus 6, minus 9, minus 3. Well, that's okay. I got to look at delta x. Plus 1, plus 2, plus 3, plus 1. Delta y over delta x, negative 3 over 1 is negative 3. Negative 6 divided by 2, negative 3. Negative 9 divided by 3, negative 3. Right there, already I can see my rate of change. These numbers are all the same. So that means, yes, it is linear. Now we need to go over here, and I'm going to have to draw a table that's a little bit bigger. And put in, it doesn't matter which number, I'll put in there negative 2, 5. Put your rate of change in there first, negative 3 times negative 2. Okay, well, when you multiply these two together, you get positive 6. What do you have to add or subtract to 6 to get to 5? Minus 1. So your equation is y equals negative 3x minus 1. Now, what if they give us just ordered pairs? You're going to want to go through and build a table. And I'm going to put in there x, and y, negative 10, 10, negative 5, and 4, 0, 2, and 5, 0. So now let's go through. We're going to find delta y, the change in y, minus 6, minus 2, minus 2. Delta x, plus 5, plus 5, plus 5. Delta y over delta x, negative 6 over 5. Well, that's as low as that goes. Let's try negative 2 over 5. Wait a minute. Are these the same? No, it is nonlinear. The rate of change must be the same. Another one with a table. Build this table right now and do delta y over delta x and see if it is linear. Two and 4, 5 and 3, 8 and 2, 9 and 1. Step 1, delta y, minus 1, minus 1, minus 1. Delta x plus 3 plus 3 plus 1. Delta y over delta x, I have negative 1 over 3. Then the second one is the same. Okay, well, that's good. But the next one says negative 1 over 1. These are not the same. They are nonlinear. If they are nonlinear, we cannot find an equation. Okay, take a second with what we've said about linear and just guess to yourself which one is linear and which one is nonlinear. In the word linear is the word line. Number 6 makes a straight line. That is linear. Number 7, that is a curve. That is nonlinear. What about 8? Is 8 making a straight line? No, it is nonlinear. Now, look at number 9. Is number 9 making a straight line? Sure is. It's a horizontal line. Maybe some of you need to remember horizontal means it goes from left to right. Now, what about this next one? I don't know about this one with an equation, but we do have our handy dandy calculator. So let's go in here and go to our calculator. Go to y equals. And we'll put in there negative 4x minus 7 and press graph. Does it make a straight line? Yes. Is this line increasing or decreasing? It is decreasing. It is going down. It is linear. And we'll just write on there that it's decreasing just to help us remember what we've already learned. Take a second and put 11 and 12 in the calculator and press graph and figure out if it's linear or nonlinear. Please do that now. Number 11, you would have gone to y equals and put in there 1/4, 1, divide 4, and x minus 8. Oh, what happened? Let me go back. Forgot the minus. Minus 8, and press graph. Is my line increasing or decreasing? Increasing. It is going up. This is a straight line. It is linear. The next one, I have 1 divide x plus 3. I press graph. Does that make a straight line? No, it's got two crazy lines going on. This is nonlinear. Okay, the third way we said was through word problems. The easiest way to do this is to make a table or write the equation where you're trying to find the coefficient and the constant. Okay, so on this one, it says Josh receives a $25 gift card to iTunes. Each song, oh, the cost of each song, that's going to tell me my coefficient is $1.25. How many songs can John buy before running out of money on his gift card? Well, if I go and build a table, I know this is going to be the number of songs, and this is going to be the amount, the money on the gift card. When he first starts out, he has $25. After he downloads one song, how much is now on the card? Should be 24. No, wrong. 23.75. And how am I getting that? Well, heck. Go here, start with 25 and subtract $1.25. That gives me $23.75. Then if I download a second song, you subtract off another $1.25, which is $22.50. 3 songs, $21.25. Well, the first thing it wants to know is it linear? That just means is delta y over delta x the same? It's going down by $1.25 each time. Delta x is going up by 1. When you take delta y divided by delta x, you get negative 125 over 1, which is negative $1.25. So yes, it is linear because they're the same. Your equation, you should see that we have, you can write it one of 2 ways. 25 minus $1.25x, or we can write it as y equals negative 125x plus 25. Let me ask you this to remember what we've done before in the last unit. Is this data going to be continuous or discrete? Why is it discrete? When you go to buy songs, you're either going to buy 1 song, 2 songs, 3 songs. Okay? You're not going to buy 1.99999 of a song. Okay? Because you have to have whole number of songs. What is the domain in this situation? Out of these 2 things, what is the domain? Number of songs is the domain. What is the range? The gift card, the amount of money on the gift card. Here's another thing that people missed. If I talked about what is the actual domain of this data, the domain is, what do you start with? Number of songs. How many songs do you first start with? 0. And it goes, does it go on forever? No, it has to stop somewhere, because when I put in here 25 minus $1.25, oh darn, I need to redo that. So the domain, I know that the number of songs cannot be a negative number. So I know I'm starting at 0 right here on my table, because that's when I have $25 on the gift card. Let's go over here and let me look at range for a second. Range, I have $25, and the smallest amount I can have on the gift card is what? 0. So my range, I'll just write it like this. I can write it a couple different ways, but I'm going to write from 0 to $25. I'll put the dollar sign right there. I could write it like this. I could write it like this. 0, that y goes from 0 to $25. Y is all the numbers in between here. Now the domain, I need to figure out when they run out of money. So when I go down here, I'm going to figure out when y is 0. And there it is. How many songs could they download? 20. So I can write, if I wanted to, I could write this a couple ways too. I could write it 0, 1, 2, 3 to 20. I could write from 0 to 20. Okay? You can't really write it like this because it's discrete. It's got to be whole numbers. Gets a little tricky on that one. But the main thing was, when we were going through this, was just finding out that it was linear. If it's linear, then we can write the equation. Okay? I just want to review some of the stuff that we did in our last unit. On our next one, It says Katie starts with $15 in her bank account. Each month, the amount doubles. How much money will Katie have after 5 months? Okay, well, let's build a table. First off, what is X and what is Y? I mean, I know X goes here and Y goes here. X is the number of months. I would have all this written down, y'all. What is Y? The money in the account. The money in the account. So when she starts off, okay, so at the very beginning, at time 0, she has $15 in her account, right? Because she goes in and deposits the money. After the first, so on the first month, it says her money doubles. How much money does she now have? 30. Wait, hold up. Second month, it doubles again. How much does she have? No, I said, why you said 45? Nick yourself. It said doubles. 60. When you double, what do? You multiply by 2. So in the third month, it doubles again. 120. Now, let's look at what's happening. If I do delta y right here, that's plus 15. What is it here? Plus 30. What about here? Okay, so now let's do delta x. Plus 1, plus 1. Why is it nonlinear? 15 divided by 1 is 15. 30 divided by 1 is 30. They're not the same. They do not have the same rate of change. It is nonlinear. Let me give you a hint. Ding, 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 ding. Hello, hello. Doubles and the word triples. Because remember, doubles is times 2. Triples is times 3. Anytime it tells you that, it is not linear. It is not linear. Anytime it doubles or triples, don't tell anybody, but it's not linear. Just saying it. Okay, so it's nonlinear when it uses those words. I know I'm a little weird. It's okay. Next one. Look at this one. Y'all ain't going nowhere. Right here. Heather works at Kroger where she earns $6.75 per hour. How much money will Heather earn after 9 months? What is the X and what is the Y if I build a table? X is going to be the number of hours, not how much they get per hour, but the number of hours they work. Y is the total money. So you would start off by saying after 1 hour of work, she has made $6.75. After 2 hours of work, how much has she made? $13.50. And yes, I'm using my noggin, but remember, we can go in here and do 675 times 2, 675 times 3, which gives me, what is that, 25? Delta y, the change in y, it's going up by 675. Delta x is going up by 1. Delta y divided by delta x is 675 over 1. It is linear. The equation is y equals $6.75 times x. What is the constant in this situation?
No.
If there's not, you're saying there's not a constant, what number represents that? 0, because you don't get paid before you go to work, right? You can put plus 0, but they'll have this equation, but it is linear, and this is the equation.